Yet another software is HTTP Recon. I hope I have it on my computer. I think I do. So HTTP Recon is specifically for daemon banner grabbing of web ports. So I type the website address here, imt.edu, and the port number 80. Click on Analyze. It will basically keep sending a bunch of HTTP commands. HTTP commands are basically commands that are used to request web pages from a remote system or a remote web server. And whenever the remote system, in which in this case is imt.edu, it receives a HTTP request, it will send back a reply. And within the reply, this is, if all of you look at the screen, this is the header of the reply. It tells us that imt.edu is running Microsoft IIS 7.5. As simple as that. So you can one by one check out all the different commands that were sent to the web server and the response that you got, so that you can get all detailed information about that particular computer or the server. And at the bottom it gives you like a match list. So it says that it's a Microsoft IIS version 7.0 with a 100% match. So you know that, okay, that's a web server running on imt.edu. So now you can easily find some loophole or exploit on the internet, which you can then use to hack into imt.edu. So that's the HTTP Recon, or the HTTP web server fingerprinting tool. It's available as a free download from this particular URL that has been displayed on the screen, or you can just do a simple Google search and download it as well. The next demonstration that I like to share with all of you is Netcat. So what exactly is Netcat and what can you actually do with it? Netcat is one of the most popular and widely used networking utilities on the internet. It can be used to read and write network connections. It is widely used by both criminals and system administrators. Netcat can be used for a variety of different functions, like listening to a particular port, connecting to a port, transferring files between two machines, chatting with somebody, executing applications on a remote computer, sending spoofed HTTP probes. You can also use it as a proxy server for port scanning and so on. One of the things that Netcat can be used for is to probe a remote computer to find out a list of open ports and the daemons and software running on these open ports. So let's see how we can use Netcat to perform daemon banner grabbing. So Netcat is available as a free download on the internet. Just do a Google search and you will be able to download Netcat onto your computer. And it runs from the MS-DOS prompt. So once you've installed it, make sure that you go to the right folder or the right directory. And the command that you got to type is nc-v followed by the website address followed by the port number 80. So you just have to wait. And wait for a timeout to take place. And once the timeout takes place, there is an error message that gets displayed, and it tells you that it's a Akamai G host running on the remote computer. So let's try imt.edu. Let's see what result we get. While it's taking place, let me type the command for all of you. So the command that you got to type is nc space -v space victim IP or victim host space victim port. So let's cause a timeout to take place. You can press enter a few times if you want. Otherwise, just wait for the timeout to take place. Essentially, within the error message, there will be some valuable information that gets revealed about the web server or the operating system being run on imt.edu. For some reason it's not showing up now. Maybe we just need to wait for longer, or maybe we need to run this again. So I'm going to try to run this again and see what happens. Okay, let's try some other website. This time we have some kind of response that has been displayed. Still waiting for a timeout to take place. There you go. So if you notice, an error took place and we got some valuable information about the victim's web server. So that's just a basic example of Netcat. Now, just the way you have Netcat, you have something called NCAT. NCAT is actually a new and improved version of Netcat. It comes free with Nmap, and it kind of allows you to do the same thing. So let's see how you can use NCAT to probe a particular remote website. So let me open up the MS-DOS prompt. I type the command ncat space capital C followed by the victim domain followed by port 80. And then once you are connected to that port 80, I type the command get/http/1.0 double enter. And when I press enter twice, an error message gets displayed. It says that your browser sent a request that the server could not understand. Essentially, since we typed a command that did not make sense and we pressed enter twice, it basically generated this error message which reveals the web server that they're running. So that's NCAT. You can also use NCAT to open a port on a local machine. So let's see, let's try this out. I open up MS-DOS and I type ncat-l followed by my own local IP address followed by port 8080. So right now it has opened port 8080 on my machine. So let me use my browser to connect to port 8080 on my own machine. So I press enter. And if I go back to the MS-DOS, if you notice, it has actually already detected which browser tried to connect to it, the version of the operating system, and so on. So it actually captured the fingerprint of the browser that connected to it. So that's the beauty of NCAT. I may have some more examples of NCAT that I can share with all of you. You can also transfer files using NCAT. So there are two commands that you got to type. First command, you open up MS-DOS and you type the command ncat-l or -i. I think it's L. ncat-l, which is listen option, 7000 greater than sign output.txt. What it basically does is this command ncat -L7000 will basically open port 7000 on your machine. It accepts input on it or incoming connections, and whatever the user inputs into it will then be saved in a file called output.txt. Now, in another MS-DOS window, you type ncat 127.0.0.1 space 7000 > input.txt. It basically connects to port 70 on your own machine. That is the local machine IP address that has been mentioned, and transfer data from the input.txt file to that port. Essentially, whatever is there in input.txt will get saved in output.txt. And you just created a simple file transfer or like a chat mechanism between two systems. Similarly, you can even transfer files from one machine to another using ncat. So in first MS-DOS window, you type ncat -L 7000 > output.txt. So as you know, this command will open port 7000 on your machine, and it will listen for incoming connections, and it will accept all the input that is received on that port. And whatever is received as input will be saved in the output.txt file. So now open another MS-DOS window and type the command ncat 127.0.0.1 space 7000. Essentially, you are now connecting to your own machine 7000 port, and now whatever you type as input will get stored in the text file output.txt. So kind of like similar to what we had created in the previous slide. So we quickly now move on to another extremely important topic within information gathering and network reconnaissance. So up until now, we have discussed how to use traceroute and ping to find out or guess somebody else's operating system. We have learned how to use LAN mapping tools and also WHOIS or DNS related tools. And then we, in today's lecture, discuss port scanning, and we also discussed daemon banner grabbing. So these are very critical and important topics. And finally, we discuss OS detection. Like the name suggests, OS detection is basically a technique that allows you to identify the operating system that is running on the target system or the victim computer. Finding out the operating system that is running on the victim computer is extremely important, because even if there's a particular software that the victim is running, and even if that particular software, there is a particular vulnerability that you found, please remember that not all vulnerabilities will affect all software running on all platforms. So usually vulnerabilities are operating system specific, which is why it's very important to even not only find out the list of open ports and the software running on the open ports, it's equally important to try and find out the operating system that is running on the victim's computer, which is where OS fingerprinting or OS detection comes into the picture. Now there are typically two types of OS detection techniques. You have active fingerprinting and passive fingerprinting. In active fingerprinting, what happens is that you as a criminal have to send data to the victim's computer and wait for a response, and whenever you receive a response, you analyze the response, you study the various fields of the data package that you received in response, and then try to identify the operating system running on the victim's computer. To be honest, OS detection is not very different from what we had done with ping, traceroute and TTL values in the previous lecture. Basically, in OS fingerprinting, what we had done manually in the previous class, OS fingerprinting tools will do it automatically for you. Where whenever the victim's computer sends some data to you, there will be some fields in the data, like TTL value or don't fragment bit value and stuff like that. So what it will do is, the software will analyze the various fields of the data packets that it has received from the victim's computer, and it will try and identify the operating system that is running on the victim's computer. Different operating systems have different stacks or different kernels. Hence, different operating systems will respond differently to the same data packet that is sent to it by the criminal. This difference in responses is used as a benchmark of differentiating between various operating systems that may be running on the victim's computer. For example, the response sent by a Windows XP computer to a packet sent by a criminal will be very different from the response that is sent by a Unix machine. I gave Windows XP as an example, but Windows Vista, Windows 7, Windows 8, any kind of Windows operating system will have a very different response to the same packet that may be sent to a Unix system as well. So the typical working of OS detection or OS fingerprinting is that the criminal will send some data packets to the victim's computer. The victim's computer will reply to those data packets, and the reply will go back to the attacker. The attacker will then analyze the data packets or try to study the data packets, and will then come up with some kind of analysis on what operating system may be running on the victim's computer. So there are actually two types of OS detection techniques available. I briefly mentioned active fingerprinting earlier. So in active fingerprinting, you as a criminal need to send data to the victim, wait for the response, study the response, and then compare it with the known values of known operating systems to identify which operating system is running on the victim's computer. But in active fingerprinting, the problem is that since you are sending data packets, and that too probing data packets that are only sent by criminals, your identity will get revealed to the victim. As a result, it is known as active fingerprinting, where you have to actively send data packets to the victim's computer. On the other hand, you have passive fingerprinting, where if you are worried about your identity getting revealed to the victim, if you're worried about getting arrested for planning this sophisticated hacking attack against the victim, then passive fingerprinting is much better for you. Because in passive fingerprinting, you have to still send data to the victim's computer, but instead of sending probing data that only criminals send, in passive fingerprinting, you may send regular data. For example, you may just open your browser and try to connect to the website of the victim, which thousands of people across the world are connecting or doing so every single day. So if you join that crowd, and if even you connect to the victim's website, it's not as if the victim is going to suddenly be able to detect that you are a criminal and everybody else is not a criminal. So in passive fingerprinting, also you need to send data to the victim's computer just like in active fingerprinting, but the difference is what kind of data you're sending. The rest of the steps are the same. Whenever you send data to the victim will have to send back a reply. And the reply you can then analyze and look into known fields like TTL values or don't fragment bit and so on, to try and identify the default values that may have been used by the system when it sent out the data packets, and then you can guesstimate or estimate or approximate the operating system that may be running on the victim's computer. So in active fingerprinting, your identity gets revealed to the victim, and in passive fingerprinting, your identity does not get revealed to the victim. So how do you perform active fingerprinting? Active fingerprinting is the art of actively sending data packets to the victim computer to generate a response, which is then analyzed and compared to the list of known responses to determine or to guess or to calculate the operating system that may be running on the victim's computer. Usually, when you get a response from the victim, the various fields that you're analyzing are the following. You're typically analyzing the window size of the packets, the TTL values, ACK values, ISN values, handling of overlapping fragments, and so on. The best part is, even active fingerprinting or OS fingerprinting can be performed using Nmap. And the commands that you got to type are either of the following. So you type nmap -o or -a So nmap-o-a followed by -v followed by the victim IP address or website. So let us see a live demonstration of this. We are running out of time, so this will be the last demonstration of today's class, after which we'll wrap up the session, do a recap and wrap up, and then I'll continue in the next class. So we'll just have to wait for a couple of minutes while Nmap performs a quick scan. Typically, OS detection takes a maximum amount of time compared to all other information gathering scans, because typically in OS fingerprinting, it basically performs all other information gathering techniques as well. So if you notice, if you look at the output, it has shown me all the open ports that exist on ankitfadia.in. It has shown me all the different services that are being offered, and then it basically kind of timed out. There was some error that took place. It says that the network distance is too long, so maybe I can try changing the command that I used, or I can try to actually get closer to ankitfadia.in, decrease the number of hops between me and ankitfadia.in. So while this is continuing, I'll probably repeat this demonstration in the next class again. So since we are running out of time, what I'm going to do is that I'm going to go ahead and quickly recap the class, and then we will come back to this in the next class, because I don't want to actually skip passive fingerprinting. I rather discuss active and passive together in the next class. So in this class, we basically covered pretty much the whole of port scanning. We started by discussing what exactly are ports. There are two types of ports: hardware, virtual ports. How to find out your own open ports, how to find out somebody else's open ports, which is what port scanning is all about. We discussed 6 or 7 different port scanning techniques, and then we also saw live demonstrations of port scanning. Then we discussed daemon banner grabbing, and we saw how to perform that live as well. And then not only Nmap, we saw other tools as well that allow you to perform network reconnaissance and information gathering. Most importantly, we learned that why finding out the name of the software and the version of the software running on an open port, why that is important. Because we did a quick Google search in a few different examples, and we were able to quickly find out some vulnerabilities that were known for that platform, that particular software name and version. So that's actually the first step that we are taking towards identifying or finding loopholes on a target system. So in the next class, I'm going to continue talking about network reconnaissance and information gathering. We'll continue at this topic, which is active fingerprinting, and then we'll move on to security auditing, finding loopholes, and then eventually we'll start talking about a variety of different types of loopholes or attacks that are possible or that can be used to actually hack into the victim's computer. So I hope all of you enjoyed today's lecture. This is Ankit Fadia. Until the next class, signing off.